Okay, welcome to Let's Get to the Marks. We're looking at physics and maths tutor. We're looking at some of their revision packs for A-Level Chemistry. So today I'm going to Inorganic Chemistry 1 on the physics and maths tutor site for AQA A-Level Chemistry. Going to questions by topic, and I want to look at the Group 2 metals, which is one of the topics you need to know inside out for your AS and your A-Level Chemistry. So you can find that by clicking on A-Level, you get on the Physics and Maths Tutor site, clicking on Chemistry Revision, then hitting Inorganic Chemistry 1, which is for the AS students, and then you scroll down and you pick Group 2 Metals. Questions by topic. Topic, sorry, God, I can't speak. And then I'm going to look specifically today at the MCQ, which is the multiple choice questions. So let's get into this. I highly recommend the Physics and Maths Tutor website. So you should definitely add that to your favorites. Here we go. AQA, Chemistry A-Level, Group 2, Metals, MCQ. Let's go. What is a use of barium sulfate? Okay, so let's go through these. Is it an in agriculture, do we use barium sulfate as a fertilizer? We don't. It's not got nitrates, phosphates, or phosphorus in it, which are the kind of important things you need in a fertilizer. Do we use it to neutralize acidic soil or as an antacid? No, we don't. Neutralizing acidic soil, we use calcium oxide, which is a base, or we use magnesium hydroxide as an antacid, which is also a base. Barium sulfate is not a base. It does not release hydroxide ions in solution. Okay, so that's the end of question 1. The correct answer was C. Question 2. Which property would you expect the element radium to possess? Okay. Is it A, it forms a soluble sulfate, it does not react with water for B, C, it's a good conductor of electricity, or D, it forms a covalent fluoride? Well, is it soluble? No, radium is not soluble. As we go down the group, um, they get less soluble. So basically, radium's right at the bottom. So radium is going to be the least soluble of the group 2 sulfates. Now, does it react with water? It says here it does not react with water. What do we know about the reactivity of metals, whether you're group 1, group 2, or group 3, as you go down the group? What happens to the atomic radii? What happens to the distance of the electrons from the nucleus? What we'll learn is that they get more reactive down the group. The electrons are further from the nucleus, there's more shielding, there's less attraction to the nucleus. So it's actually easy for them to react with water as we go down the group. They get more reactive. Radium's right at the bottom, so again, we would expect it to be one of the most reactive of the group 2 metals with water. Now let's look at C. Is it a good conductor of electricity? Well, what you have to ask yourself here is, does it have delocalized electrons? And the answer, of course, is it does have delocalized electrons. So it is a good conductor of electricity. In fact, it forms a 2+ positive ion, and it's going to have lots of delocalized electrons. So it's going to be a fairly good conductor. That doesn't mean that we should use it as a metal in industry for conducting electricity. It's far too reactive and would make a useless material in a wire. So does it form a covalent fluoride? So would we get radium fluoride? Well, radium fluoride would be a metal and a non-metal, so it would be ionic. It would not be a covalent compound. Right, let's look at question 3. Which statement is not correct? So we're looking at which one of these is not correct. Strontium has a lower first ionization energy than calcium. Strontium has a larger ionic radius than calcium. Strontium reacts less vigorously with water than calcium. Strontium hydroxide is more soluble in water than calcium hydroxide. Let's check them out. Okay, first up, which statement is not correct? Well, the first one is true. Strontium has a lower first ionization energy than calcium. Yeah, it's going to require less energy to remove the electron in strontium. Why? It's further down the group than calcium. Its electron is further away from the nucleus. Less electrostatic force of attraction to that outer electron, as there's more shielding as well. Easier to remove. It will require less energy. So that's a true statement and not our answer. B, strontium has a larger ionic radius than calcium. Well, yes, it's further down the group. It has more shielding. It has more shells. It has a larger ionic radius. This is also a true statement. Strontium reacts less vigorously with water than calcium. Ah, that could be a problem, see. Why is that a problem? Well, as we go down the group, we've already said with the top one, the electrons are further from the nucleus. They require less energy, lower ionization energy, in order to remove the electron. Therefore, they're going to be more reactive down the group. So I would say that is the incorrect statement. It should read strontium reacts more vigorously with water. Of course, the last one, strontium hydroxide, is more soluble in water than calcium hydroxide. That's not true. As we go down the group, they become the hydroxides become less soluble. Oh, sorry, they become more soluble. So it's true. Yeah, I was going to say the sulfates become less soluble, the hydroxides become more soluble as you go down the group. Question 4. Which property of the group 2 elements, calcium to barium, increases with increasing atomic number? Sorry about that. My phone was just ringing. Okay, well, let's see which one is increasing with increasing atomic number. And well, as you go from calcium to barium down group 2, obviously the atomic number is increasing. But let's just look at the others. Would the electronegativity increase? Electronegativity increases to the top right of the periodic table. So no, as we go down a group, you always become you always become less electronegative. Even top right, fluorine, which is above chlorine, is more electronegative. As you go down from chlorine to bromine to iodine, you become less electronegative. Would the first ionization energy increase? No, because the atomic radius has increased. It means that you've become more reactive. It's more easy to lose an electron, more shielding, more shells, larger radius, outer electron further from the nucleus. And the melting point, well, won't go too much into it, but as you go down a metal group 1, 2, or 3, you do get lower melting points because the metallic bonds become weaker. Okay, let's move on to question 5. So the correct answer there was A. So what is the correct observation when barium metal is added to an excess of water? So does it form a colourless solution? Well, essentially, this is the group 1, you remember from GCSE, form hydroxides and release hydrogen gas. Well, guess what? Group 2 do that as well. The alkaline earth metals. They produce a hydroxide solution and release hydrogen gas. So we've got the exact same reaction going on for the majority of them, especially as they get more reactive. Now, they're only ever going to form colourless solutions because unless you're a transition metal, you're going to form colourless solutions. But also we're going to see hydrogen gas come off, and that's the effervescence or the bubbling. Okay, if they're insoluble, then you might get the white precipitate forming if you have an insoluble hydroxide forming. But if you have a hydroxide that's soluble and it's a group 1, 2, or 3 metal, then it will be a colourless solution. As we know, group 1, 2, and 3 metal compounds do form white precipitates or white solids. An aqueous solution of a salt gives a white precipitate when mixed with aqueous silver nitrate and when mixed with dilute sulfuric acid. What or which could be the formula of the salt? Well, you kind of know both of these from GCSE as well. What does silver nitrate test for? Well, it tests for chloride ions. So here with the potassium chloride, that would definitely give you a white precipitate with silver nitrate because you get that white precipitate with chloride ions as part of the test. You add nitric acid and you add silver nitrate. Here, however, we've also got sulfuric acid. Can you remember from GCSE, also in ASA level, what is the test for sulfate ions? And the test for sulfate ions is add barium chloride because, of course, barium combines with SO4 2- to make barium sulfate, which is a white precipitate. You should remember for A-Level or AS chemistry, you have to remember that barium sulfate can be used in X-ray imaging. It coats the lining of organs like your stomach, your esophagus, your intestines in the digestive system. You can have a barium meal and that coats the inner lining of those organs, which absorbs the X-rays and appears white on an X-ray. Okay, the fact that it's insoluble does that. Okay, let's move. Question 7. Which substance is used to reduce titanium 4 chloride in the extraction of titanium metal?
So you just have to kind of know this off by heart. Titanium, you're going to need something more reactive. Titanium's not too reactive, but we're going to use magnesium here, quite high up the reactivity series, and and not too expensive. Magnesium metal plus titanium chloride 4. Now, you'd think it would be solid because it's an ionic compound, but this is done at 1,000 degrees. Okay, so at that temperature, that becomes a vapor, TiCl4, and it's vaporized into a gas. You have to know that. We add that to magnesium, and that's going to make magnesium chloride and leave little titanium on its own. It's a displacement reaction in essence. You've got redox obviously going on as well, and you get your pure titanium metal, which can be used for your hip replacements and various bits and bobs, as it's got a low density ish and it's unreactive. Question 8: which statement about barium sulfate is correct? So it is soluble at a temperature of 100 degrees. Well, no, barium sulfate, we don't want it to be soluble. We want it to absorb those X-rays in medical imaging. It is used in medicine because it does not dissolve in bodily fluids. Now, that's the one. We don't want it to dissolve in bodily fluids. We want it to coat the lining of the organs. So B is the correct answer here. It's a pale yellow solid. Barium's a group 2 metal. Remember what we just said, group 1, group 2, group 3, they form white compounds. Okay, so group 2 metal compounds, they're all going to be white, unless they're going to contain a transition metal, which is going to give them some color. Okay, it reacts with acidified barium chloride solution. Yeah, that's not going to happen. So we're looking at B is the correct answer.
Okay, let's move on here, guys, to question 9. Which compound is used to treat the symptoms of indigestion? Well, indigestion is caused by excess stomach acid, and you've got magnesium oxide, magnesium hydroxide, calcium oxide, and calcium hydroxide. All of these can neutralize acids. However, for AQA, the one we need to know that's used as an antiacid is actually magnesium hydroxide. So the answer is B. Magnesium oxide in real life is actually used as an antiacid too, but for AQA, we need to know MgOH2. Calcium oxide is used to neutralize sulfur dioxide gases out of the flue or chimney of power stations. So that can be used, or calcium carbonate, and calcium hydroxide is slaked lime, what we use in the carbon dioxide test. It's basically lime water. Um, cool. So the answer here is B, and you do need to know magnesium hydroxide is used as an antacid to neutralize excess stomach acid. Let's move on. Okay, question 10. Which products are formed when magnesium reacts with steam? So we've got magnesium hydroxide and hydrogen, magnesium hydroxide and oxygen, magnesium oxide and hydrogen, magnesium oxide and oxygen. So it's a little bit different than when metals react with water. They normally form a hydroxide and hydrogen. So this is the variation here with this group 2 metal magnesium. When it reacts with steam, it forms magnesium oxide and hydrogen instead of the magnesium hydroxide and hydrogen. So we get Mg plus H2O, that's in the gaseous form, it's steam H2O, and it forms solid magnesium oxide, which is a white or grey solid, and you get formed hydrogen gas. You might be asked about an observation as well here. You can see a white light. All right, question 11. Which of these decreases down group 2? So is it the first ionization energy? Does that decrease as you go down a group? No, yes. Well, we'll look at that in a second. Let's start at the bottom here. That should give you a clue what the answer is. But is it the reactivity with water? Obviously, as we go down the group, the atomic radius gets bigger, the electrons become further from the nucleus, less electrostatic attraction. There's also more shielding, which further reduces the electrostatic attraction between the nucleus and the outer electron, meaning that there's less energy to remove that, so it's more reactive. The number of protons obviously increase as we go down the group. These atoms are getting bigger, more protons in the nucleus, so think calcium has 20 protons, magnesium 12. The atomic radius, well, that's getting larger as we go down the group, right? because we're adding electron shells with each, as we go down, we add one shell. So really, all of these point to the first ionization energy is what decreases. It's easier to remove the electron, so we need less energy. Okay, let's move on to the last question. So just once again, group 2, as you go down, just like all the metal groups, the general pattern is it gets easier to remove the electron. They're further from the nucleus. And what do metals want to do? They want to be oxidized. They want to lose their electrons. So as they go down the group, those electrons being further from the nuclear attraction makes that an easier process. So we get a lower first ionization energy. The answer is A here for question 11. Okay, final question, guys. 12. Sulfur dioxide is produced when some fossil fuels are burnt. Which of the following statements are or is true? Sulfur dioxide can be removed from waste gases in a power station by adding an acid and base reaction with calcium oxide. Sulfur dioxide is insoluble in water. No, it's not. It forms acid rain in the clouds, as you know that from GCSE. Sulfur dioxide is a basic oxide. No, you should know off by heart that non-metal oxides are acidic. Metal oxides are basic. Sulfur dioxide is an ionic compound. No, it only contains non-metal elements, so it's a simple covalent molecule, sulfur dioxide. And of course, sulfur dioxide is removed with calcium oxide, which is this first answer, from flues or chimneys in power stations, or you can use calcium carbonate. Guys, hit the like, leave a comment if you enjoy these PMT walkthroughs. Let's go, let's get to the marks.
You're still here? It's over.